In this video, we consider the case where the characteristic equation has complex roots. Consider the constant second order differential equation giving us ay double prime plus by prime plus cy is equal to 0, and its associated characteristic equation giving us ar squared plus br plus c is equal to 0. Now suppose the roots are complex conjugates, thus r is equal to alpha plus beta I, where alpha is the real part and beta is the imaginary part. Then the general solution is giving us y of t is equal to c1e alpha t cosine of beta t plus c2e exponent alpha t sine of beta t. This can be simplified as, so here we can factor e exponent alpha t, so that's e exponent alpha t, then c1 cosine of beta t plus c2 sine of beta t. Example 1. Solve the initial value problem. Y double prime plus 4y is equal to 0, y of 0 is equal to 1, and y prime of 0 is equal to 0. The first step is to write the characteristic equation. So we are going to have r squared plus 4 is equal to 0. Then we find the roots of this equation. So solving for r, we are going to have r squared is equal to minus 4. Thus r is equal to plus or minus the square root of minus 4. And this is equal to plus or minus 2i. So we have the roots to be complex numbers. Thus our general solution will be giving us y of t is equal to e exponent in the real part. So the real part here is 0. Then multiplying c1 cosine of the imaginary part, so that's 2t, plus a constant, say c2 sine of the imaginary part, so that will be 2t. And so this is our general solution. This simplifies to c1 cosine of 2t plus c2 sine of 2t. Let's compute the particular solution. So we are going to substitute in the initial conditions. So with the first initial condition, we have y of 0 is equal to 1. Thus we are going to have 1 is equal to c1 cosine of 0 plus c2 sine of 0. This simplifies to 1 is equal to c1 multiplying 1 plus c2 times 0. And so we have c1 to be equal to 1. To compute c2, we need to compute y prime, then we substitute in this initial condition. So computing y prime, we are going to have y prime of t is equal to, so we are going to differentiate cosine, which is going to give us minus sign. So that will be minus 2 c1 sine of 2t plus we now differentiate sine, which will give us cosine. So we are going to have 2 c2 cosine of 2t. So we substitute in the initial condition. So we have the initial condition to be y prime of 0 is equal to 0. And so we are going to have 0 is equal to minus 2. c1 is known to be 1, so that will be 1. Then sine of 0 plus 2 c2 cosine of 0. So we are going to have 0 is equal to, sine of 0 is 0, so this part will be 0. Then plus 2 c2, since cosine of 0 is 1. And so we have c2 to be equal to 0. Hence our particular solution will be giving us y of t is equal to, c1 is now 1, so that's going to give us cosine of 2t, plus c2 is now 0, so that will be 0 times sine of 2t. So thus we have our solution to be cosine of 2t. Example 2. Solve the initial value problem y double prime plus 2y prime plus 5y is equal to 0. Y of 0 is 0 and y prime of 0 is equal to 1. The first step is to write our characteristic equation, and so we are going to have r squared plus 2r plus 5 is equal to 0. Now let's solve this equation. So solving for this equation, we are going to have r1, r2 to be equal to minus 1 plus or minus 2i. Thus we have the real part to be equal to minus 1 and the imaginary part to be plus or minus 1. So let's form our general solution. Our general solution is giving us y of t is equal to e exponent the real part, which is minus 1 times t into bracket c1, then cosine of 2t plus c2 sine of 2t. Now let's compute our particular solution. By the first initial condition, we have t is equal to 0 and y is equal to 0. Thus, 0 is equal to e exponent 0 multiplying c1 cosine of 0 plus c2 sine of 0. Now, cosine of 0 is 1 and sine of 0 is 0. So we are going to have 0 is equal to c1. So we have c1 to be equal to 0. To compute c2, we need to differentiate y of t. And to differentiate y of t, we need to apply the product rule. So let's differentiate y of t. Y prime of t is equal to, so here we are going to keep this guy. Then we differentiate e exponent minus t. So that's going to give us minus e exponent minus t multiplying c1 cosine of 2t plus c2 sine of 2t. Then we now keep e exponent minus t. Then we differentiate the trig function in here. So we are going to have plus e exponent minus t. When you differentiate cosine of 2t, you're going to have minus 2 sine of 2t. So that's going to give us minus 2c1, then sine of 2t. Then we now differentiate sine of 2t. That's going to give us 2 cosine of 2t. So that will be plus 2c2 cosine of 2t. Then we substitute in the initial condition. So we have y prime of 0 is equal to 1. Thus 1 is equal to minus e exponent 0, then c1 cosine of 0 plus c2 sine of 0 plus e exponent 0, then minus 2 c1 sine of 0 plus 2c2. This simplifies to 1 is equal to minus 1 multiplying c1, because cosine of 0 is 1 and sine of 0 is equal to 0. So this part will be 0. Then plus e exponent 0 is 1. So here's going to be 1. Then sine of 0 will go to 0 and cosine of 0 is 1. So that will be 2c2. Now, what's the value of c1? That's 0. So we are going to have this guy to be equal to 0. So we have our final result to be 1 is equal to 2c2. Thus c2 is equal to 1/2. Hence the particular solution is y of t is equal to e exponent minus t. c1 is 0, so here's going to be 0 cosine of 2t plus c2 is 1/2, then sine of 2t. So this simplifies to 1/2 e minus t, then sine of 2t. So this is our particular solution. Example 3. Solve the initial value problem. Y double prime minus 2y prime plus 5y is equal to 0. Y of 0 is equal to 2 and y prime of 0 is equal to 0. The characteristic equation is giving us r squared minus 2r plus 5 is equal to 0. Solving this equation gives 1 plus or minus 2i. And so our general solution will be giving us y of t is equal to e exponent 1t c1 cosine of 2t plus c2 sine of 2t. Now let's solve for a particular solution. So with the first initial condition, y of 0 is equal to 2, we have 2 is equal to e exponent 0 c1 cosine of 0 plus c2 sine of 0. Sine of 0 is 0, cosine of 0 is 1, so we are going to have, and so we are going to have c1 to be equal to 2. To compute c2, we need to find y prime. So y prime will be giving us, so we're going to use the product rule. So that's et, then c1 cosine of 2t plus c2 sine of 2t, Then we now keep e exponent t, then we differentiate the trig functions. So plus e exponent t, so when we differentiate cosine of 2t, we're going to have minus 2 sine of 2t. So that's going to give us minus 2 c1 sine of 2t, then plus 2 c2 cosine of 2t. By the initial condition, we have y prime of 0 is equal to 0. Thus, we are going to have 0 is equal to e exponent 0 c1 cosine of 0 plus c2 sine of 0 plus e exponent 0 minus 2c1 sine of 0 plus 2c2 cosine of 0. So sine of 0 is 0 and cosine of 0 is 1. So this expression simplifies to 0 is equal to c1 then plus 2c2. But c1 is equal to 2. So we are going to have 0 is equal to 2 plus 2c2. Thus we have minus 2 is equal to 2c2. Hence c2 is equal to minus 1. Thus, our particular solution is giving us y of t is equal to e exponent t. c1 is 2, so that's going to be 2 cosine of 2t. c2 is minus 1, so that's going to be minus sine of 2t. Thank you for watching. See you in the next video. Bye.